So in our previous sessions, we have started with the discussion of our modules and what are the data types we have started. We have started with our discussion of our data types. What are the type of data types which we have? Rich data type, wired data type, and the size of this data types. What is the width of each data type? Also, we have discussed and a different type of net data types we have discussed with the width of each data type and the default values of the data types and where this data types is used, why data type where it is used, and how the execution is happening. Okay, this and all things which we have seen, and we have also started with the rich data type. We have seen the default value keyword for that particular thing, default value and default width and unsigned, and we have also seen that is a that it's an unsigned data type. And after that, we have started with our integer data type. We have seen our with about our integer data type and float data type we have seen. And after that, we have started with our vectors. Vectors, we have seen the definition, syntax, and we have also seen that vectors, the size can be declared in the big Indian format and little Indian format. We have seen and how to declare the vectors and what is meant by this vector slicing. Also, we have discussed. Okay, this and all things we have discussed in our previous sessions. Now, in this particular session, we will start with the discussion of port connection rules. This is a very, very important concept because as a fresher, as a beginner level, we will get many confusions in this port connections. So let us try to understand this port connections in more detail, how to make the connections and okay, this and all things first. Let us try to understand. First, let us see about port connection rules. Then we will see how to connect different modules. First, let us see about port connection rules. Now we need to understand. You can keep this particular diagram in your mind. So this will help a lot. This particular diagram will help a lot for keeping, for understanding this particular concept. Now let's say this is our design A. This box is our design A, and this rectangular box outside this design A is our test bench. You can say it as a test bench. Basically, a test bench is also a module which is going to provide the stimulus to the design. Okay, so design, if we want to check whether our design is working correctly or not, we should provide some stimulus, right? Okay, so using our test bench, what we are going to do is we are going to provide some set of stimulus to our design. That is, we are going to provide the input, and our design is going to provide some set of outputs corresponding to the set of inputs you are providing. Okay, now the outputs which we are getting from our design, we are collecting it in the test bench. So after collecting those particular values in the test bench, we are going to cross verify with the expected values. Okay, like let's say suppose if we are writing a test bench for a full adder. Now, if we for a full adder we have inputs A, B, and C in, and we have the output sum and carry. Okay, so let's say if the inputs are 0, 1, 1, then our sum should be equal to 0 and carry should be equal to 1. Right? This is the expected result which we should get from our design. That is nothing but full adder. Now, who is providing this inputs A, B, and C into our design? Test bench is providing this stimulus to our design. Okay, now test bench is provided, have provided this particular stimulus to our design. Design will provide this output, that is sum is equal to 0 or carry is equal to 1. Okay, and that will be collected in our test bench. Okay, now the collected values will be cross verified with the expected values, that is 0 and 1. If we are getting the same values, expected values, then we can confirm that, then we can make sure that our design is working correctly. Or else we will come to know that okay, our design has some fault in that. We will go back inside our Verilog code and we will cross verify where is the exact bug we are having. Then we are going to rectify that. That is a process we are. That is why we are going to develop our test bench and we are going to verify that. It is a simple testing purpose. Okay. Now, so for that we need to understand how we are going to connect two modules, or not only two modules, how we are going to connect different modules. Okay. For that we need to understand this port connection rules. And let's say I have a design A. So for this design A, I'm not going to care about the code which is inside the design A. I am going to care about the ports which have been declared. Like let's say suppose design A has some input ports, input A, B, and let's say output ports as output C, comma D. So design A has this type of ports and some code which has been written and followed by end module. We have this particular code. Now, can anyone tell me what will be the data type of this A and B? So any variable which has been declared inside our Verilog should have some particular data type associated with it, right? So what do you think? What is the data type of A and B? Here I have mentioned, uh, I haven't mentioned anything. Yeah. So someone was saying something. So what will be the data type of A and B? Any idea? Anyone? Exactly. So this data type is by default net data type. So please remember this. In Verilog, if you declare any signals as input ports, then by default that particular data type will be net only. Okay. Let's say if you are explicitly writing reg, then what happens? Will it accept? If we are explicitly writing input reg a comma b, will it expect? Will it accept? Okay. What may be the reason? So implicitly, the data type of your A and B will be net only. If you mention or if you don't mention, implicit will be it will be net only. But if I'm explicitly writing input reg A comma B, then is it going to accept or not? And if it is not going to accept, why? Okay, simple explanation for this. Your inputs are going to be continuously changed or it is going to be continuously driven, okay, by the test bench. If you are using a reg data type, then you cannot use this reg data type for continuously driving the values. Okay, reg is basically going to update on the particular events. Okay, but wire it is going to be continuously updated on particular. It is going to be continue. It is used for continuously updating the values. Okay, so that's why the compiler it is not going to accept this reg. If you explicitly mention the reg also, the compiler will not accept this input of type reg. Okay, this you should be careful when you are developing the code also. If you explicitly write down reg, it will not accept. Okay. Now coming to this output C comma D. Now what is the data type of this C comma D? Can anyone tell me? Output C comma D. Exactly. So this particular C comma D will be net itself. Okay. If you don't mention any data type, that will be considered as net. Okay. If you are not mentioning any data type for this C and D, then that will be considered as net data type. But if you mention explicitly as reg, then it will be considered as reg data type. So output can be of reg or output can be of net. If you want to store the data in the output variables, then you are going to declare them as reg. And if you don't want to store any data inside your output ports, and if you just want to drive the data, then you are going to declare it as net. Depending upon your requirement, whether if you want to store the data, you declare explicitly as reg, or if you don't want to store the data, then don't declare any data type. That will be considered as your net data type. Okay, this is how your ports data types are being declared. Okay, is it clear for everyone? Any doubts or any queries in this? So these are my designs, input ports and output ports A, B and C and D. A and B, as we have discussed, these are of input ports. A and B are input ports, and by default we have seen that A and B are of net data type. I will write down one more time here. A and B are of net data type. Okay, the reason and that and all things we have discussed just now. And coming to C and D, they can be wire or they can be rich. If you haven't mentioned any data type, that will be considered as net. But if you mention any data type, that will be considered as rich. Okay. So here my C comma D can be of net or can be of rich. Can be of net or can be of rich. This I have written here. Okay. Now I should provide some values to A and B. Who is providing the values to A and B? The test bench is providing the values to A and B. Okay. So I should declare the variables in my test bench also, right? I should declare my variables in the test bench also. So I'm going to declare the test bench variables which are going to be connected with our design variables. So this test bench variables are denoted by A underscore TB and B underscore TB. Okay. Now this A underscore TB will be connected to A and B underscore TB variable will be connected to B, and whatever the values which we are storing inside this A underscore TB, that is going to be reflected inside A, and whatever the values we are going to store inside this B underscore TB, that is going to be updated inside our B. Okay. Now our question is, what should be the data type of A underscore TB and B underscore TB? what should be the data type? Internally inside the module, our data type of A and B are of net. Now my question is, from the test bench, when we are connecting it with A and B, then what should be the data type of A underscore TB and what can be the data type of B underscore TB? Okay, any other answers? Okay. So this A underscore TB and B underscore TB of can be of reg or it can be of net data type. So you can either declare it as A underscore TB and B underscore TB, or either it can be of reg or either it can be of net. Okay. Why reg? The reason for declaring them as reg, that is nothing but we can store any data in this A underscore TB and that can be connected to A, so that the storage of this, the stored data inside this A underscore TB will be directly connected to our designs variable, that is A and B. Okay. Now, what is the reason for declaration of net is, let's say suppose we have one more design like this. We have one more module which is being present here, somewhere here. And let's say this module is connected with this module. Okay, this module is being connected with this particular module. Now, if I want to connect this particular module and design a module, then what data type should I use for connecting these two modules? For connecting these two modules, what type of data type I should use? Either rich or wire. Exactly, net. So in that particular case, you need to declare this A underscore TB and B underscore TB of net. In this particular case, you should declare these two variables A underscore TB and B underscore TB of net. Or else, if you think you're not going to connect this, connect any other module, then you can simply declare it as reg. Okay, then you can simply declare that particular A underscore TB and B underscore TB of reg. But if your requirement is that you are going to connect this module and this another module inside your test bench, okay, inside your test bench you are going to connect these two modules. Actually this module is inside the test bench, there is no space, that's why I'm drawing it outside the test bench. If you think that inside your test bench you are going to connect two modules, then you are going to provide this A underscore TB and B underscore TB of net. Okay, or else you can just simply them as rich. Okay, and one more time I'm repeating, this particular module is present inside the test bench. Here there is no place, that's why I'm drawing outside the test bench. Okay, so this is what how we are going to declare our variables. Okay, is it clear? Anyone needs explanation again? Is it clear? Great. Now, coming to this right hand side. Now, what is the data type of C and D? The data type of C and D is of type reg or wire. The data type of C and D is of type reg or wire. That we have seen already inside our code also we have seen. Okay, here we have seen. It can be of reg or it can be of net. Net or wire, you can say something. I will use net. Okay. Now, coming to collecting these variables, that is, I'm going to declare two variables, C underscore TB and D underscore TB are two variables which I'm going to use for collecting these values. Now, what should be the values? What should be the data type of C underscore TB and D underscore TB is my question. Anyone wants to guess C underscore TB and D underscore TB? What should be the data type of C underscore TB and D underscore TB? Exactly. So C underscore TB and D underscore TB should be of net only. This C underscore TB and D underscore TB should be of definitely net type only. I will write down here C underscore TB and D underscore TB, which are my test bench variables, should be of net type only. They cannot be of rich type. Why they cannot be of rich type? Because again the same explanation. Here, if we have one more module like this, and if I want to connect this C and this D with my another design like this, okay, then this C underscore TB and D underscore TB which I am using for making these connections, this cannot be of reg type. If you are using this as a reg type, then you cannot connect these two modules. If you declare them as net only, it will accept it. Okay, so that's why the compiler, what it has been set is your output variables which is been collecting the designs output, this should be of only net type only, it cannot be of reg type. Is it clear? So are they clear? Any doubts or any queries in this? Okay. So let me draw this particular diagram more neatly so that the things will be more clear. This is my design, and I have an input port like this. And input port internally it is of only net data type, that the reason we have seen. And we have an output port, and the output port can be of rich or it can be of net. This also we have seen. Okay, the reason also we have seen. And the test bench or any other module which is being connected with the output port of our design should be of only net. And the test bench or any other design which has been connected with the input port of our design can be of rich or can be of net. Okay, and there will be one more port which is nothing but in-out port, and this in-out port can be of net only. Okay, and outside the module also it should be of net only. It should be of net only. Okay, this diagram you need to remember for connecting the different modules. Okay, now let us see how to make these connections. So connections can be made between different modules by two ways. One is connection by name, and another is connection by order. So connections can be made in two ways. One is connection by name, and another is connection by order. Okay, so let's see what is this connection by name and connection by order. Let us try to understand. So first of all, let us try to understand this connection by name. Now, let us take this design of full adder using half adder, and let us try to understand with design how to connect this, how to build this design using connection by name. And this is my full adder. Okay, and I have A, B, S, and C. A, B, S, and C. Okay, and this full adder has three inputs: A underscore FA, B underscore FA, and C in underscore FA. And here I have S underscore FA and C underscore FA. These are my outputs and these are my inputs. Now, and these two adders are connected. S and C, S and A are connected, and we have this C in being connected to this B, and from this C we are going to have here, and this C is being connected over here. Here we are going to have an OR gate which is being connected to this, and S is connected to this. Okay, and this A underscore FA is connected to A, B underscore FA is connected to B. This is how we are going to build a full adder using half adder. This we already know. Okay, now if I want to connect this two modules, I definitely need a wire. Okay, now can anyone tell me how many wires do I need in this particular design? You can take few minutes of time, and can anyone tell me how many wires do I need in this particular design? Okay, I got one answer. Three. Okay, let's see. Let's see how many wires do we need. So for connecting this S and A, and that is nothing but our this two modules connection, we need one wire. I'm going to represent this as W1. Okay. Now for connecting this half adder with this OR gate, this OR gate is also a module, or it's a design. Okay. If you want to connect this half adder and this OR gate, you need one more wire. This is W2. Let me represent this as W2. And if you want to connect this half adder with this OR gate, you need one more wire, that is nothing but W3. And elsewhere you don't need any wire, because this input is directly connected with this design, and this input is also connected directly with this design, so no wire is needed. And the Cin is directly connected to our design, so no wire is needed. And the sum is directly connected to the output, so no wire is needed. And the C is also connected directly to the carry, so no wire is needed. If you want, you can declare. Okay, if you want, you can declare the wire also, but it is unnecessary. Okay, no need, because it is a direct connection. Now, so we have came to know that we need three wires. Okay, now If you want to develop this code, first of all, what you need to do is you need to develop the code for half adder. You need to develop the code for half adder. How you are going to write the code for half adder? Simply write down module, followed by module name, followed by inputs, input A comma B comma output. If you want to store the output, you can declare it as rich, or if you don't want to store the output, you can simply leave it s comma c. Okay, and followed by the code of the half adder. After seeing the gate level, behavioral level, I will explain you how to write the code for half adder. But now, what is our main concern is I need to see how we are going to connect these two modules. Okay, I've written the code and end module. Okay, now you don't need to write the code for two times. If there are two modules, you don't need to write the code for two times. Only write the code for one time. Okay, that's it. Only write the code for the design of half adder only for one time. That's enough. Okay. Now after that, what you are going to do is you are going to write down the code for our full adder. How to write the code for our full adder module? Module name, input ports. Input ports of our full adder are A underscore FA, B underscore FA, and C underscore FA. And what are our output ports? Our outputs are output S underscore FA and C underscore FA are our output ports. Now, here I am going to connect my full adders input ports with my half adders input ports. How I should connect is step one. So what you're going to do is you should write down your design name. Okay, what is your design name? Your design name is half adder. Okay, so design name is HA. So you should write your design name followed by you should give your instance name. So you should name this block. Let's say it is HA1 and this is HA2. Okay, these are my instance names. That's it. For avoiding the confusion, I'm going to give the instance name. This HA and the instance name is HA1. Okay, this is my instance name. You can give any name. There is no restriction in this. Okay, and I should connect this by connection by name. Okay, now how to connect this by using connection by name is I'm going to use this particular syntax dot dot followed by variable name followed by brackets comma dot variable name followed by brackets comma dot followed by variable name followed by brackets. And how many I have? Four, right? I have four, or sorry, for half adder I have four arguments: 1 2 3 4. Let me erase this. So how many arguments it is expecting? That many arguments we should provide. Comma dot comma dot. Okay, now, so before outside the brackets, you should mention the variables which are associated with our half adder. Now, what is the variable which is associated with our half adder A that you are going to mention here? Let me use one more color. So you are going to mention outside the variable the uh, variable which is associated with our half adder. Next here B. Next, what is present? S. Okay, dot s and dot c. This is how you are going to mention. Okay, this a, this b, s and c, these are the variables of our half adder. Okay, variables of half adder. Now inside the design you should mention the variables related to your full adder. Okay, now so this half adders a is connected to a underscore fa. So I'm going to write it down a underscore fa. I'm going to write down inside my bracket a underscore fa. I'm using arrow mark because there is no place here. You should not use arrow mark. You should write a underscore fa. Okay. And my half adder b is connected to b underscore fa. I'm going to write it down b underscore fa. B underscore fa. Okay. Now half adder sum is connected to which module? Can anyone tell me? So what should I write inside my bracket? What should I connect this sum with? I should write a, or what should I write inside my bracket? So inside my bracket I am going to write down w1. Okay, because if you see your sum is connected to this wire, your sum is connected to this wire, so inside your bracket you are going to write down w1. Okay. And what is your carry is connected to? Carry is connected to wire W2. Carry is being connected to wire W2. So you should write down W2. Okay. And you should also declare wires here. I haven't declared here. I will declare here wire W1, W2, W3. Okay. Outside the brackets, these are the variables which are related to your half adder, and inside the brackets, these are the variables which are related to your full adder. Okay. And is it clear up to here how you are making the connections? Is it clear? Anyone any doubts? All clear it? Yes. Now coming to second half adder. Okay. HA2. Okay. Now again same. So how you are going to write down? So outside the brackets, you are going to mention your half adder variables dot A, comma, dot B, comma, dot S, comma, dot C. This is how you are going to mention. Okay. Now inside the brackets, what you are going to do is you are going to mention your variables which are related to your full adder. Now, what is this A connected to? The second half adders A is connected to the wire W1. So you are going to write down here W1. Okay. And second half adder B is connected to the variable scene underscore FA. So you are going to write here scene underscore FA. And second half adder sum is connected directly to the output port, that is S underscore FA. You are going to write down S underscore FA. And second half adder carry is connected to wire W3. So you are going to write down here W3. You are going to write down here W3. Okay. These are my two half adders which I have instantiated. This particular process which I am doing is nothing but connection or instantiation. This particular process is known as instantiation. Okay. I'm going to write down here instantiation by name. Okay. And there is no restriction that you should follow a specific order. In connection by name, there is no restriction that you should follow a specific order. For example, you can simply write down HA1, and you can start with giving dot B of this is my half adder set, dot B comma dot A comma dot C comma dot S. No issue. There is no restriction that you should follow a specific order. Here you can write B in underscore FA, B underscore FA, A underscore FA, and here you can write where it is connected to wire W2 and it is connected to wire W1. There is no restriction that you should follow a specific order in the case of your connection by name. Okay. So this is how you are going to connect, and followed by we have one more OR gate, right? So for OR gate we have a gate primitive which we can use, OR followed by C, what is the variable which is associated with half adder, C underscore FA, comma W2 comma W3. Okay. What is this instance? What is this OR gate? How we are providing that and all we are going to discuss in the gate level modeling. Okay. So this is how we are going to follow connection by name for connecting our variables. Is it clear? Any doubts or any queries here? Shall we move forward? Great. Okay. Now let us see how to follow connection by order. Connection by order. Okay, again the same code which I'm going to take HA1, and now in the connection by order we are not going to write down the variables which are related to our half adder. Previously what we were doing, we are writing the variables of our half adder and we are connecting with the variables which are corresponding to our full adder. But now in the connection by order, we are not going to write down the variables which are related to our half adder. We are simply going to write down the variables which are related to our full adder. Now here the order is very important. What do you mean by order is, whenever you are writing the code of your half adder, what is the order you have followed for declaration? First you have declared input, and first you have declared A and B. Next you have declared output S and C. And when you are connecting the variables by connection by order, if you are writing A underscore FA, comma, B underscore FA, comma, wire W1, comma, wire W2. Okay. You're not mentioning the variables of your half adder, just you are mentioning the variables of your full adder. Then what is happening? This A underscore FA is connected to half address A, and this B underscore FA is being connected to half address B, and this wire W1 is connected to sum, and this W2 is connected to carry. Let's say suppose if you are writing HA1 B underscore FA, comma E underscore FA, comma W2, comma W3, then what is happening here? Then what will happen is B underscore FA will be connected to half address A, and A underscore FA will be connected to half address B, and this will be connected to sum, and this will be connected to carry. Because the order is this A, B, S, C, but what you're writing B, A, W2, W3, then there will be a mismatch. Okay, this is wrong. So in connection by order, you should be very careful how the order has been declared. Okay, so generally there are only 4 ports here, so that's why there will be no confusion. But if you are having multiple ports, then you should be very careful in the order in which they have declared. Many mistakes will be happening in the connection by order, not in the beginning level, but when you go and when you are dealing with more number of signals, then there will be definitely at least 2 to 3 mistakes definitely people will be doing. Okay, so you should be careful in the connection by order. Okay, and if you don't feel connection by order as your it's simple, then you can follow connection by name. Okay, connection by name assures that you are making a correct connections only. Okay, so this is nothing but by connection by name and connection by order and port connection rules. Is it clear? Any doubts or any queries in this? Great. Okay, now so let us see one example. We have a module like this, and we have one more module like this, and this module is being connected over here, and we have one more module like this. Okay, so we have some variables x and y which are associated here, and we have a and b, c and d, m, n. Okay, and this variable has some variables, let's say p, q, r, s. Okay, and this has some input ports, let's say k and l, and it has some output ports, let's say c and d. There's some variables we have now. So let us see what should be our variables, what should be our data types, and how we are going to make this. Coming to this M and N, what should be the data type of M and N? Can anyone tell me? What should be the data type of M and what should be the data type of N? Okay, first let us start from here. What should be the data type of C and what should be the data type of D? What should be the data type of C and what should be the data type of D? Exactly. This should be of only, this can be of net or rich. There is no restriction that there should be net only. Okay. Port connection rules we have seen, right? So C and D can be of rich or can be of net. Rich or net. Depending upon requirement. This can be of rich or this can be of net. Okay. Now, what should be the data type of A and B? It can be of only net inputs, right? So it should be of only net. Okay. Is it clear? Now, coming to M and N. Coming to M and N. What should be the data type of M and what should be the data type of N? What should be the data type of M and what should be the data type of N? Exactly. This can be of only net. This can be of only net. Okay. Now, what should be the data type of X and Y? What can be the data type of X and Y? Exactly. Rich or net. Now, coming to this P and Q. What should be the data type of P and Q? No, this P and Q can be of only net. This P and Q can be only of net because, okay. Now, what should be the data type of R and S? Yeah, no issue. What should be the data type of R and S? This R and S can be of only net only because these are our outputs of this module, right? It can be of only net. Okay. And coming to this K and L, it can be of reg or net, reg or net. And coming to this C and D, it can be of only net. This can be of only net. Is it clear how we are making these connections? Is it clear? So this is how we are going to connect our modules, and these are our connection rules. Okay. Yes. So that's all about this session. And in our next session, we are going to, and yeah, one more small points I wanted to discuss here. Let me complete the things also. 1 minute. And any doubts in this slide? No doubts, right? Great. Let's say we have a module like this, and we have another module like this. This is module A and this is module B. Okay. And this is, let's say the variable is M and N. And this variable is M underscore B and N underscore B. Now the module A parameters, that is nothing but M and N. These are of only 1 bit. Okay. This M is of 1 bit and N is of 1 bit. I will write down here also, it is of only 1 bit. Okay. Whereas coming to this M underscore B and N underscore B, that is a module B parameters, M underscore B and N underscore B. Let's say it is of 4 bits width. Let's say it is of 4 bits width. Now, what do you think if we are connecting this M underscore B and N underscore B with M and N, do we get any compilation errors? What do you think? This N underscore B is of 4 bits width and M underscore B is of 4 bits width, and this M and N is of only 1 bit. Now, if we are trying to make these connections, what do you think? Do we get any compilation error? No, we will not get any compilation error. We are not going to get any compilation error. Then what is going to happen? Then this from this M underscore B, which is of 4 bits width, only 1 bit will be connected. That is only LSB will be connected. Okay. So what is going to happen is you can assume this of 4 wires. I will draw it from here. I will draw it in another perspective. So this is our module A and this is our module B. Okay, this is our module B. And this is our M and this is our N, which is of 4 bits width. This is my M, which is of 4 bits. That you can assume 4 bits as 4 lines. Okay. So 4 lines are present here and N is also having 4 lines. And this M has only capacity to connect with 1 line. So what is happening? Only the LSB will be connected. This is MSB and this is my LSB. So only the LSB will be connected with my A. Only the LSB of M underscore B will be connected with the bit, that is M. Okay. And remaining will be not connected. They will be left unconnected. And here also only the LSB will be connected and remaining will be unconnected. Okay. This is nothing but this particular concept is known as width mismatch. If we try to mismatch the width also, there is no issue. But it is not recommended. Width mismatching is not recommended. Okay. And same with the output ports also. And same with the output ports also. Is it clear? This case one, is it clear? Great. Now let's see one more case. Let's say if we have a module like this, and these are our inputs A, B, X, Y. These are my input ports and these are my output ports. Let's say if my input ports are unconnected like this. If my input ports are unconnected, there is no connection which is present. I'll represent it with the diagram. Then what is going to happen? Do we get any compilation error if input ports are not connected? If my input ports are not connected, then what is going to happen? Am I going to get any compilation error if my input ports are not connected during my instantiation? During the instantiation, let's say if my inputs are not connected. So during the instantiation of my design inside my top model, if I'm leaving these ports as unconnected, then I'm going to get a compilation error. Okay. So you must always drive the inputs when you are connecting with your design. If you are instantiating your design inside another module, then you must always connect your inputs. You must always drive the inputs. Okay. Here we are going to get compilation error. Okay. And let's see this case also. If we are if we are not connecting our output ports, let's say this is x underscore top and y underscore top. Then do we get any compilation error if we are not connecting our output ports during the instantiation? So during our instantiation, if we are not connecting our output ports, then we are not going to get any error. No error in this particular case. Okay. So you can leave your output ports unconnected. No error in this case. But if you leave your input ports unconnected, you are going to get error. But if you leave your output ports unconnected, you are going to get error. Okay. Let's see one coding example for this. Let's say suppose if you are writing module top, and let's say you are declaring two variables rich uh, m comma n and wire x underscore top and y underscore top like this. Okay. And if you are instantiating this design, let's say the design name is design itself. Okay. So design d1, and I'm following connection by order, let's say. Okay. So how to leave your port unconnected? If you're simply writing comma, then you are leaving this port unconnected. You are leaving your input port as unconnected. And if you are writing one more comma, you are leaving two input ports as unconnected. Then in this case, you are going to get an error. Okay. If you write x underscore top and y underscore top by leaving your input ports unconnected, then you are going to get error saying that input ports must always be driven. Okay. Input ports are unconnected, and you are going to get error. Okay. And let's say suppose case 2, let us say if you are leaving your output ports as unconnected, let's say design d2, and if you are writing let's say m comma n comma comma, that means you are leaving your output ports as unconnected, then you are going to get no error in this case. You can leave your output ports as unconnected, then you are not going to get any error. Okay. So these are some of the rules which we should follow while instantiating our designs. Okay, we will see the coding examples also. This particular things you should be remember. You should remember this so that when we start our coding and when we start building our modules, then this simple rules will be very much helpful. Okay. Yes. And one more final case, like let's say suppose this design has having four arguments, two input arguments and two output arguments, and if you are leaving by not providing, let's say you are only providing two arguments, m and n, that's it. Then what is going to happen? Do you get? Are you going to get any error if you are not providing the arguments of last two arguments? Any idea? If I am writing simply design D3 m comma n, design is expecting four arguments, but if you are providing only two arguments, do you get any error in this case? We will get the error. If you are not providing the sufficient number of arguments, you are going to get error. Okay, because you are not providing full argument. In this case, you are providing the argument. It is an empty argument, and here also it is an empty argument, so you are providing one, two, and two empty arguments, so four arguments you are providing, but here you are not at all providing the empty argument also. That's why you are going to get an error. Okay, there is a difference between providing empty arguments and providing no arguments at all. This type of errors we face a lot, so people who are just started with their coding, this type of errors they are going to face. If they simply don't provide the arguments, the sufficient number of arguments, then you are going to get error. But if you provide empty arguments in the case of output, you are not going to get any error. Okay, and if you are not providing the or if you are providing empty arguments for your inputs, then also you are going to get error. Okay, so these are the things you should be careful while coding. Okay, yes. So that's about this particular session. I hope you have got a clear idea about what is this arguments, what is port connection rules, what is how to connect these ports, and what is everything related to this port connection rules. Okay, yes. So that's all about the session. If you have any doubts or anything you wanted to discuss with me, you can stay and discuss with me, or else you can leave the session. Okay, thank you.